All right, so in this video, we are going to be reviewing factoring because there are different methods on how to factor. So we're going to be tackling different methods. So first thing you have to know is what is factoring, right? So polynomials can be factored out in different ways depending on how many terms they have. So when you see a problem on your homework or on your test that says factor, you first have to identify what kind of problem you have. So first thing you're going to do is ask yourself, do I have a binomial? And a binomial is a polynomial that has two terms. Do I have a trinomial, which is a polynomial that has three terms? Or do I just simply have a polynomial with four terms? These are the three different types of polynomials you're going to learn how to factor in this section. So first thing, right, before you do anything, remember the first thing you're supposed to always factor out is the greatest common factor. So before you start factoring anything, always factor the greatest common factor first, which is what we're going to go over next, right? So in case you don't know what the greatest common factor is, from now on I'm just going to be calling GCF. It's the greatest common factor is the largest polynomial that divides evenly into each term. So for example, here we have two terms, right? We have 6x to the fifth and 4x to the third. How do I find the GCF? How do I find the greatest common factor? Well, all you have to ask yourself is what's the biggest number that goes into 6 and also goes into 4? So the biggest number that goes into those two numbers is 2. So that's the greatest common factor. But since this one also has x, you have to ask yourself, what is the greatest common factor of x to the fifth and x to the third? An easy way to remember that, it's always going to be the smallest exponent. So since this one has 5 x's and this one has 3, the most I can take out from both of them is 3 x's. So my greatest common factor is simply 2x to the third. So again, the 2 comes from the 6 and the 4, and then the x to the third is always going to be the smallest exponent of the two terms you're looking at. All right, so let's go ahead and try another one. Find the greatest common factor of x cubed, y cubed, x squared, y to the fifth, and x fourth, y to the seventh. Again, just like we did on the previous problem, you separate, look at all the x's. Which one has the smallest exponent? It would be this one, so that's going to be the greatest common factor, but we also have to look at the y's. Which y has the smallest exponent? It would be this one. So there we go, that's going to be our greatest common factor. Our greatest common factor for these three terms would be x squared, y to the third. Okay, so again, just remember, look for the smallest exponent. All right, since you already know how to find the greatest common factor, we're going to start by practicing a problem on factoring, right? So when we tell you factor a polynomial, you always factor the greatest common factor first, and this is what you do, right? So let's look at this one. Factor out the greatest common factor from the polynomial below. So we have three terms. Remember, the first thing you always do is find the greatest common factor. So let's look at the numbers first. 6, -9, and 12. What number goes evenly into all those numbers? So hopefully you can think about it and you can right away tell me, right? The biggest number that can go into all those three numbers is the number 3, right? So that's going to be one of our greatest common factors. But remember, all of these terms also have an x. So which x has the smallest exponent? It would be this one, because if it doesn't have an exponent, it's an imaginary one. So there you go. My greatest common factor is 3x. And then once you find your greatest common factor, in order to factor out, what you do is that you put it outside and then you open parentheses. So we're going to open parentheses. And then all of the terms here are going to have 3x, right? It's not that hard to do. So what you do is that you divide the 6 by 3, so that gives me a 2. And then think about it. If I had 3 x's and I took one out, now I'm going to be left with 2. So what's happening is that I'm subtracting the exponents. All right, that wasn't that bad. Let's try the next one. So now here, what is -9 divided by the 3 that I took out? It's going to be -3. And again, think about the x's. If you had 2 x's and you took one x out, the 9x squared just becomes now a -3x. All right, and then the last one, 12x. Remember, you took out a 3, so you divide. 12 divided by 3 gives me a +4. And now this one only had one x, but since I factored out the x outside, there's no more x's, so the 4 just stays by itself. Okay, so that is how you factor out the greatest common factor, right? So you first have to identify the greatest common factor, then you just pull it outside, and then in parentheses, you write all the leftovers. All right, so since we already covered the greatest common factor, which is the first thing you always factor out, now we're going to see how to tackle different types of problems, right? So if I give you a polynomial and you already factored the greatest common factor and you're left with a binomial. Again, a binomial is a polynomial that has two terms. Binomials are only factorable, which means they can only be factored if they fall into one of the three categories. They could be a difference of two squares. And again, don't panic if you don't know what that means. We're going to go over it. It could also be a difference of two cubes, or it could be a sum of two cubes. So a binomial can only be factored if it falls into one of these three. If it doesn't, then it's not factorable. But again, don't panic. We're going to go into every single one of these in a little bit. So let's go ahead and start with a difference of two squares. If a binomial, and don't panic, right? If a binomial looks like this is what we call a difference of two squares. So if the first term is a perfect square and the second term is a perfect square and they're being subtracted, you're going to be able to factor it like this. You're going to put the first term in the parentheses. You're going to put the second term on the outside of the parentheses. And then one of the parentheses is always going to have a plus and the other one's always going to have a minus. Okay, if you have no idea what I'm talking about, don't worry. This is what we call a difference of two squares, and I'm going to tell you why. The first term is being squared. The second term is not being squared, but we know that 25 is a perfect square. So what we do is that we're going to rewrite this problem. X squared minus 25 can actually be written as x squared, and 25 can be written as 5 squared. So that's why this problem is called the difference of two perfect squares. Okay, I'm hoping that made sense. So from now on, when you have a binomial, ask yourself, is this a difference of two squares? Is the first term a perfect square and is the second term a perfect square? If they're perfect squares, then you could just factor out this super easily. What we do is in one parenthesis, we're going to put x plus 5, and in the other parentheses, we're going to put x minus 5. And then look at that. That wasn't that bad. This is how you factor out x squared minus 25. All right, we already went over a difference of two squares. There is such a thing as a difference of two cubes. Now, the formula for this one is kind of a bit longer. So if you have a binomial that has two perfect cubes, and remember, cubes is a number that you can raise to the third power, right? And you could get a separate number. So I'll give you an example right now because I know I said it very confusing. So if you have a binomial that has two terms that are perfect cubes, this is the formula you're going to use. And again, you have to make sure you have this on your notes. So the formula for a difference of two squares was a plus b and then times a minus b. Now this one changes up a little bit. Okay, so I'm going to show you how to use that formula in a little bit. So here we go. We have a binomial, and again, this is a binomial because it only has two terms. And you should notice, and this should give it away, this is a difference of two perfect cubes. How do you know? Well, let's see. Here we have x to the third power, which means cube. So that one's a perfect cube. Now ask yourself, is 8 a perfect cube? Is there a number that when I raise it to the third power gives me 8? The answer to that is yes. X cubed minus 8 can be rewritten as x to the third power minus 2 to the third power, because 2 times 2 times 2 is actually 8. So look at that. That was pretty cool. This polynomial here is the difference of two cubes. Now what we do is now we use the formula. This right here is your A. This right here is your B. So all I'm going to do is I'm going to rewrite this. For every time where you see an A, I'm going to put x. And every time you see a B, I'm going to put a 2. So look at this. This is what it's going to look like. And again, don't let it freak you out. So look at this. X minus 2. Here we have a squared. So in my problem, it's going to be x squared. Here we have a times b. So my problem is going to be x times 2. And then here I have b squared, which in my case is 2 squared. Now, of course, now we just simplify. Here you can't do much. Here you cannot do a lot. Here you can simplify, right? X times 2 just gives us 2x. And then 2 squared is 2 times 2, which is 4. And then look at that. Again, I don't think that was that terrible. This is the factored form of this. So we solved the problem, right? All they ask us to do is factor out. We noticed that it was a difference of two cubes, so we applied the formula, and that's what we got. All right, the third formula you have to know for factoring binomials is what we call the sum of two cubes. Please do not confuse this formula with the one we just went over, which was this one. If you notice, they're very much alike, but these signs change, right? So here you go, that's how they change. Okay, so this one, we use it when we have a sum of two cubes. So if there's a plus sign in the middle, that's how you know we're going to be using this one. So again, let's go ahead and look at the problem. So you open up your homework, you open up your test, and you see this, and I ask you to factor. So remember, it's a binomial. You ask yourself, okay, is it a sum of two cubes? Is it a difference of two cubes? Or is it a difference of two squares? So what gives it away is this right here. This is a sum, right? So you should be asking yourself, okay, now let's check. Is it a sum of two perfect cubes? Let's see. Is this cubed and is this cubed? The answer is yes, right? So this right here is being cubed. The 8 is not being cubed, but we can rewrite the 8 as a number to a third power. And that number, again, we did it on the last slide, is 2. So again, a perfect cube is a number that can be rewritten as something to the third power, right? In our case, it would be 2 because 2 times 2 times 2 gives us the 8. Now, once you do this, once you rewrite it, this takes your A value. So again, let me go ahead and put in A. Very crooked A, I'm sorry about that. And this takes place of your B. And then all we do is rewrite it using the formula. So the X is going to go in all the A's. And then the 2 is going to go in all the B's, right? So I go ahead and do that here. And it's just like the last slide. But if you notice, the signs are different because this is a formula for when we have a sum in the middle. So again, I'm just going to go ahead and tell you what we did. We replaced them, and then we do this right here. X times 2 is 2x. And then the 2 squared is a 4. So again, this is not complicated. Just make sure you have the formula handy and that you know that you're using the correct one if you have a sum or if you have a difference. All right, so now we're going to go ahead and try a couple more problems just so we could have a fresh start. Right? So here we have a problem and you have to figure out what kind of formula am I going to use. Right, so first thing you're going to notice, and remember, the first thing you always do is factor the greatest common factor first. Don't forget that. But here, there's no number that goes into 25 or 16, so we don't have a greatest common factor. This one has an m, this one has a y, so I can factor out a variable. So this one, no greatest common factor. Now let's see, does this one fall into one of the three formulas we talked about? So first thing I want you to see is that there's a difference. So this one could be a difference of 2 squares, or it could be a difference of 2 cubes. Now, what do you think it is? Okay, hopefully you said, oh, it's a difference of 2 squares. Then yes, you're correct. Congratulations. This is a difference of 2 squares. Again, this gives it away, right? This is a square, this is a square. And then this should also give it away. 25 is a perfect square and 16 is a perfect square. So this one is a difference of 2 squares. So what we do is that we rewrite it. I'm sorry for changing the slides, but you rewrite it, right? 25m squared can be rewritten as the square root of 25 is 5. And the m is also being squared, so this is 5m squared. And then the 16y squared is also a perfect square, right? 16 is actually 4. And then the y is also being squared. So this is how you know this is perfect squares, right? The difference of perfect squares. So all we do, remember the formula, if you go back to the formula for the difference of 2 squares, it just says put the first one on the first 2 parentheses, put the last one in the last 2 parentheses, and remember one of them is always plus and the other one's always minus. Okay, so I'm hoping that made sense. So again, difference of 2 squares. All right, let's go ahead and try another problem here. Again, hopefully you're getting used to this. Now again, this one, you notice the difference. Hopefully you notice the squares. But here some of you are going to panic because you're like, 48 is not a perfect square and 75 is not a perfect square. So before you put your foot down and say, oh my goodness, this one cannot be factored, remember what I told you. What is the first thing we always factor out? We always factor out the greatest common factor first. Okay, so that's why maybe this one is not making sense yet. So the first thing we do, again, let me just put a little note here, is your greatest common factor has to always be factored out first. So what number goes into 48 and also goes into 75? So I'm not going to make you think and break your head, right? That number is actually 3. So if I factor out a 3, and that's a must, you always have to factor the greatest common factor. If I factor out a 3, I divide the 48. So 48 divided by 3 gives me the 16. And then 75 divided by 3 gives me 25. So look at that. I factored out a 3 and I factored out, and then be aware, right? Some of you are going to stop and be like, oh, ma'am, that's my final answer. No, right? You still have to check this. Maybe this could be factored out even more. So let's see. So inside the parentheses, I have a binomial. And hopefully some of you, your brain is kind of itching right now and telling you, hey, this is a difference of perfect two squares, of two perfect squares, right? Don't forget that you could still factor out more if that's the case. So hopefully some of you can see that 16a squared is actually 4a to the second power. Oh my goodness, I'm so sorry about my parentheses. And then 25b squared is actually 5b squared. So that means that those are two perfect squares and it's a difference, so I can factor that out even more. So this would be my final answer. Don't forget the 3 is still outside. So if you forget to write the 3 on your final answer, then your final answer will be wrong. And then this, I factored it out using the difference of two squares, right? The 4a and the 4a, the 5b and the 5b, 1 plus, 1 minus, and voila. Okay, so look at that. So I want you to see these type of problems where you first have to factor the greatest common factor and then you apply one of the formulas. All right, let's go ahead and try a couple more. Here we have two problems. And again, I know some of you are jumping off the board and like, I know how to do this one, and you already factored things out. Just be very careful. Hopefully we all agree that this is a perfect square, right? This is 4x squared. And then this little one here is also a perfect square, right? 81 is actually 9, and then the y squared. Now my question to you is, can I use the formula we've been using, the difference of two squares? If you said yes, ma'am, they're perfect squares, I'm so sorry, you cannot use the formula, because remember, the name of the formula is the difference of two squares. Is this a difference? No, it's not. There is no such formula called the sum of two squares. So if you ever run across one of these problems, this is what we call a prime polynomial. So no formula applies to it. This is the sum of two squares, which we don't have. We have a formula for the sum of two cubes, but not as of two squares. So this is what you call a polynomial that's not factorable. You would write it's a prime polynomial. All right, let's keep on practicing here. Here we have another binomial. Again, the first thing you always factor out is the greatest common factor, but there's no number that goes into 8 and 125. So now we ask ourselves, okay, does this one fall into one of the three categories? Is it a difference of two squares? No, right? 8 is not a perfect square, so no. Now the second question, is it a sum of two cubes? No, because there's no sum in the middle. Now the third formula, is this a difference of two cubes? The answer would be yes, right? This is a sum of two cubes because 8 can be rewritten as 2 to the third power, and 125 can be rewritten as 5 to the third power. And obviously the a is being cubed and the b is being cubed, right? So that's what we do. So on this one, you would take out your formula for the difference of two cubes. If you want to write that on your notes, right? So you know what formula you applied. So the formula goes like this, right? Your formula says a. Remember, this is going to take your value of a. And this is going to take your value of b on your formula. So every time you see an a, which is here, you're going to put 2a. Here, you're going to put 2a. And here, you're going to put 2a. Everywhere in the formula where you see a b, you're going to put 5b, which is here, 5b there, and 5b there. And then remember, the formula for this one has a minus between these two, a plus between these two, and then a plus at the end. So if you have no idea how I did this, remember, just go back to the notes, previous slides, and look for the difference of two cubes. So this is what we did. Of course, you're not done there because we have to simplify, right? This one comes down the way it is. Be very careful here. When you square everything. So 2 squared gives me 4, and then a squared. 2a times 5b gives me 10ab, right? 2 times 5 is 10, and then ab is ab. And then here, remember, you also square both of these. So 5 squared gives me 25, and then the b squared is that. And then that's it. That's as much as you can simplify. So this whole little monster here is your answer for this right here. So when we ask you to factor, again, ask yourself, what's the greatest common factor? And then you ask yourself, does this one fall into one of the three different binomial formulas? All right, let's try one last one here before we move on to the next topic. Okay, what do you think for this one? Let's see. Greatest common factor, you could factor out the greatest common factor first. If this one's already perfect, two perfect cubes or two perfect squares, then we would go ahead. So again, first thing you always do remember is the greatest common factor. So this one, the greatest common factor would be 4. Again, if you don't know how I got that number, just ask yourself, what's the biggest number that goes into 108 and 32? And then just give it a couple of tries, right? I found out that 4 goes into both of them. So 4 goes into 108, and I divide it, and I get 27x to the third. If I divide 32 by 4, I get -8. So this is how I got this part here. All I did was take out the greatest, oh my goodness, that's so crooked, greatest common factor. All right, that's what I did. Now again, you don't know you're done, right? Because now you have to check this little thing right here. This one is a difference. Now, is this a difference of 2 squares or a difference of 2 cubes? And again, who cares about the 4? Right now, we're just looking at the 27 and the 8. This one is a difference of 2 cubes because 27 can be rewritten as 3 to the third power. And we already saw earlier that 8 is a perfect cube. It's actually 2 to the third power. So look at that. I rewrote it. And the 4, don't forget about it. It's still kind of the problem, even though we're ignoring it kind of, but it's still there. So now that you know that this right here is a difference of 2 cubes, you pull out your difference of 2 cubes formula, which says that you're going to bring, again, this is your A right here, 3x, and your B is the 2. So every time you see an A on your formula, you're going to put 3x, 3x, and 3x. Every time you see a B on your formula, you're going to put a 2. So 2, 2, and 2. Where am I getting the signs from? The formula. Just look at the formula. The formula says put a negative here, put a positive here, and put a positive here. And then the 4, I just brought it down. If you notice it's not bothering anyone, you just bring it down. All right, we're almost done with this one. Now we simplify. Again, there's almost never anything to simplify here. 3x squared, remember you square both of them, so it becomes 9x squared because 3 squared is 3 times 3, which is 9. 3x times 2 is 6x, and then 2 squared gives me the 4. This would be your final answer. Now, again, some of you are going to forget about the 4 we took out earlier. Please do not forget that is still part of your answer. If you don't put it, it will be counted wrong. All right, so I think that was enough for binomials. Like I said earlier, factoring depends on what kind of problem you have. If you have a binomial, it falls under one of the 3 rules we just discussed. Now, what in the world do we do if we have a trinomial? If we have a trinomial, which means a polynomial that has 3 terms, we're going to be using a little method called the product and sum method. This method is always going to work when you have a trinomial, right? But again, like I told you earlier, you always have to factor the greatest common factor first. So always and forever do the greatest common factor first and then tackle the problem, whatever you're left with. So I'm going to go slowly over the steps. If they don't make sense, don't worry, just write them down. And then when we do an example, you'll see what I'm talking about. So when you have a trinomial, which again is a polynomial that has 3 terms, step number 1, you're going to multiply A times C, which is the first coefficient and the constant at the very end. And you're going to have to find 2 numbers that multiply to whatever A times C gives you, but they add to B, which is the middle number. Again, you're like, what in the world is she talking about? Don't worry, we're going to do an example. So find 2 numbers that multiply to A times C and they add to B. Once you find those 2 numbers, step number 2, you're going to place them in this format. You're going to place, you're going to put parentheses. You're going to put X on each parentheses. Of course, if that's the variable, if your equation has Y's, then you're going to put Y's. And then the 2 numbers that you find are going to be placed here, just like that. Sometimes they're going to be positive, sometimes they're going to be negative. So we'll be talking about how those signs change in a bit. All right, once you place them in there, step 3, and please do not forget this step. This is an important step. Once you find the 2 numbers here, you're going to divide both of these numbers by A. And remember, A is the number in the very front. So you're going to divide these numbers by A. And then step 4, if for some reason you end up with a fraction, which is going to happen sometimes, but don't freak out. If you end up with a fraction, all you have to do is bring the denominator to the front. Okay, so again, right now, I don't expect these steps to make sense. Just make sure you have them jotted down on your notes, and then let's see if we could figure out a problem right now. All right, so look at this. This is what your problems are going to look like. Here it says factor completely, and this is the first thing you're going to do, right? If this shows up on your test, you're going to stare at it intensely and ask yourself, what kind of problem is this? So remember, step one is always and forever factor the greatest common factor. Now, the greatest common factor here would be 1. That's it. There's no greatest common factor, right? 2, 15, and 7 cannot be divided by any number besides 1. So now I could tackle the problem with the next step. You should notice that this is a trinomial. So whenever you come across a trinomial, remember, okay, we're going to use the product and sum method. We can no longer use the 3 formulas from the beginning because that only applied to binomials. Now we have a trinomial. So we're going to tackle it using the steps we discussed. Step 1, if you go back to step 1 on the previous slide, it says multiply A times C. So the first number and the last number. So let's come to our problem. If we multiply A times C, this is your A and this is your C. 2 times 7 gives me 14, right? That's what we did. Multiply 2 times 7 is 14. So we're going to have to stop and think, okay, what are two numbers that multiply to 14, but they add to 15 because that's the middle number. So again, if I lost you, let me just say it again. The product and sum method is always like this. Two numbers that multiply to whatever these two are. 2 times 7 is 14. So they multiply to 14, but they add to the middle number, which is positive 15. So I'm going to give you 10 seconds there. What are two numbers that multiply to 14, but when you add them, give you 15? So hopefully you agree with me. Those two numbers are 14 and 1, right? What is 14 times 1? Well, it gives me 14. And what is 14 plus 1? It gives me 15. So you kind of have to stop there and think. Since I found those two numbers, all I have to do is put them inside parentheses. So I put the x's, which is my variable here, and then the two numbers I found go in there. So x plus 14, x plus 1. All right, we're barely on step number 2. So that's what you do. All right, step number 3, and this is a very important step that a lot of students forget. Step number 3, you divide both numbers you found by a. And remember, a is your front number. So I come over here and the two numbers that I found, which is 14 and 1, I divide them by 2 because that's the number in the front. If this would have been a 7, I would have divided by 7. If this would have been 123, I would have divided by 123. So since this one was a 2, I divide by 2, and then you simplify. What is 14 divided by 2? That ends up being a pretty number. That's 7. So that just becomes a 7. Now 1 divided by 2, that's an ugly fraction. So right now I'm going to leave it like that. Okay, so 14 divided by 2 gives me 7. 1 over 2 just stays as 1 over 2. Now, like I said on step number 4, if you end up with a fraction, which we did here, don't panic, it's super easy. You move the denominator to the front. Denominator is the number on the bottom. So all I'm going to do is this ugly fraction. To get rid of it, I'm going to move that denominator to the front. Not all the way to the front of the problem, but only to the front of its parentheses. So look at that. My answer becomes x plus 7. And this little monster here with a fraction just becomes 2x plus 1 because the denominator came to the front. And what do you think? That was it. That is how you factor out a trinomial. Product and sum. So we multiplied the first number and the last. We found two numbers that multiply to that. They add to the middle one. Once you find those two numbers, which were 14 and 1, we divided them by the number in the front. And then we simplified. And then if we had a fraction, we just move the number to the front. And that's it. That's how you factor out a trinomial there. All right, let's try a couple more here just to make sure we're good. So factor completely again. You stare at it, you tell yourself, oh my goodness, this is a trinomial. Teacher said, first thing we always factor out is the greatest common factor. So the greatest common factor, in the last problem that we didn't have a greatest common factor, let's see if we have one here. Can all these numbers be divided by a number? So hopefully your answer is yes. All of those numbers can be divided by 3. So our greatest common factor is going to be 3. But to make our lives easier, I'm going to give you a huge tip. Every time you have a negative in the front, also factor it out. So my greatest common factor is going to be -3. You don't have to, but trust me, it's going to make your life so much easier because you get rid of the negative, you pull it outside, and we don't have to worry about it anymore on the inside. So what I'm going to do is I'm going to factor out the greatest common factor. I take out the -3 and all of the numbers I divided by -3. So negative 3x squared divided by -3, I'm just left with an x squared. Positive 24 Once I divide it by negative 3, gives me negative 8, and of course the x. And then positive 60 divided by negative 3 gives me the negative 20. All right, so hopefully we're all okay there. I factored out the greatest common factor. But of course, we still have to check because maybe we're done, maybe we're not. Every time you factor out the greatest common factor, now you ask yourself, can I factor this even more? So again, you stare at it, it's still a trinomial, so I'm going to try to do product and sum. So let's see if it works out. If it doesn't, then it's a prime polynomial, maybe. But let's see. So product and sum says multiply the first number and the last number. Now, I don't see any number here in the front. That means that it's an invisible 1. And again, we don't care about the negative 3 right now because we're just focusing on the inside of the parentheses. The negative 3 is not important right now, but it is going to be part of our final answer. So what is 1 times negative 20? It's negative 20. So I'm going to have to find two numbers that multiply to negative 20, but they add, or they have a sum of negative 8. And that's a really ugly S. I'm so sorry. So two numbers that multiply to negative 20 but add to negative 8. So hopefully you see that those two numbers are negative 10 and positive 2. And this is where we have different signs. Don't let it freak you out. So two numbers that multiply to negative 20, we had to use negative 10 and positive 2 because negative 10 times positive 2 gives me the negative 20. Now when I add them, what is negative 10 plus 2? That gives me the negative 8 in the middle. Okay, so sometimes your signs are going to be different. That's perfectly fine. Just make sure you find the two numbers that satisfy your requirements. Okay, are we done? Of course not, right? So remember, step 2 says find those two numbers. Step 3, hopefully you remember, you divide those numbers by the number in the front. Now, please make sure you make a note of this. What is the number in the front? If you said negative 3, I'm so sorry. No, it's not. Because remember, we're only focusing on this, right? What's the number in the front? 1. So I divide both numbers by 1. But does that do anything? No, right? So once I divide both numbers by 1, the negative 10 over 1 stays negative 10. The 2 over 1 stays 2. Now, is this my final answer? Hopefully you said no, right? My final answer is that and then the 3 I had factored out earlier. Okay, so on this one, we didn't have to move any denominators because we didn't have fractions. So that was my final answer. But again, don't forget the 3 we factored out earlier is still in the front. We didn't use it much at the end, but it's still part of the problem. Okay, so hopefully that made sense there. All right, this is how you factor trinomials. Now, I know you're asking, right? What if I have a polynomial that has 4 terms? So up to this point, you guys already know how to factor a polynomial with 2 terms, which is a binomial. You know how to factor polynomials with 3 terms, which are trinomials. Now we're going to factor polynomials with 4 terms. So again, this always applies after you factor out the greatest common factor. So remember, that's always step number 1. When you want to factor something that has 4 terms, we do this little thing called grouping. Okay, so let's go over the steps. So first step number 1, factor the greatest common factor, just like always. Step number 2, what you're going to do, since you have 4 terms, you're going to factor your polynomial, or you're going to group your polynomial in 2 groups. Okay, so we're going to be talking about that a little bit. Step number 3, once you have 2 groups, you're going to factor the greatest common factor from each group. Step 4, you're going to rewrite by factoring out the common binomial. And don't panic, I know this makes sense right now. And then step 5, if unsuccessful, repeat the steps grouping differently in step 1. So I am going to warn you, sometimes this is not going to work, but we just have to go back and regroup. So this is what you do, right? So let's go ahead and try this problem, right? So this is what, let's say again, you open up your homework, this is what you see. First thing you're going to notice, this one has 1, 2, 3, 4 problems. So your brain should be telling you we're going to do factor by grouping because it has 4 terms. Now, remember the first thing you always do is factor out the greatest common factor, but we don't have a greatest common factor because 2 and 5 cannot be divided by any number. All the terms, not all the terms have an x, not all the terms have a y, so there's no greatest common factor. So since we don't have a greatest common factor, now we can start by grouping. So let me walk you through this problem and show you how it's done. First thing you do is you group them. So since you have 4 terms, I'm going to group the first 2 together and I'm going to group the last two together. So that's how I got that. You could always start like this. I am going to warn you though, if this doesn't work, we're going to have to come back and rearrange the terms to group maybe the first one with the third term and the second with the fourth, right? So on and so forth. But let's go ahead and try it like this. Now, once you group these two, you're going to tackle the problem separately. You're going to factor the greatest common factor from here, and you're going to factor the greatest common factor from there. So what you did is you split your problem into two mini problems. So look at this right here. The greatest common factor of these two is x because they both have an x in common, right? So I factor out the x, and if I factor out an x from here, the x exponent drops down to 1. And if I factor out the x from here, I'm just left with 5y. Now, from these two, the greatest common factor is actually 1, right? 2 and 5 cannot be divided by anything. X and y, they don't share a variable, so the greatest common factor is just 1, but I do factor it out so you can see it. So I factor out a positive 1. If I factor out a positive 1, the 2x stays the same, and the 5y stays the same. All right, hopefully we're all okay up to there. Now, once you do this, I promise you, we're almost done. You know you were successful if inside the parentheses, you have the same thing. If you were not successful, don't worry. You would just go back and regroup, and I could walk you through that. But this one, we were successful. So all you have to do now, and it's super easy, but let me see if I don't lose you. If you end up with the same parentheses on both, whatever you have in the front, the x and the positive 1, go in one parentheses. And then the parentheses that repeats itself, you just write it once. And then look at that. You factored out a polynomial with 4 terms. That's what you do. So that's how you know we were successful. So again, this applies to when we have a polynomial with 4 terms, we factor by group. All right, let's go ahead and try one last problem here. Again, I tell you to factor by grouping, but if this problem shows out of nowhere, you should know on your own that this is grouping because we have 1, 2, 3, 4 terms. Again, step number 1, factor out the greatest common factor, but there is no greatest common factor because 21, 9, 14, and 6 cannot be divided by a number. No, they can't. Do all the variables share an m? No. Do all the terms share a y? No. So there's no greatest common factor. So again, what we do is that we group them. We group the first 2 terms, and right where the parenthesis ends, we open the parentheses for the next 2 terms. Now, tackle this on your own, right? What is the greatest common factor of these two? So 21 and 9 can both be divided by 3, and they both share 2 m's, or m's, remember, you always look at the smallest exponent. And then they both have y's. The smallest exponent is y to the 1. So the greatest common factor on the first one is 3 m squared y. So that's the greatest common factor. I pull it out. And then I have to divide those 2 terms by that. So 21 divided by 3 gives me 7. I had 3 m's. I took 2 out. I'm left with 1. And I had 2 y's. I factored 1 out. I'm left with 1. Now 9 divided by 3 gives me -3. The 2 m's were factored out and the y was factored out, so that's why there's nothing there. Okay, hopefully we're good up there. Now on the next problem, we look for the greatest common factor of these two. We ignore the first part of the problem. 14 and 6 can be divided by 2, so that's why that's my greatest common factor. I cannot factor an m because the 6 doesn't have an m. I cannot factor a y because the 6 doesn't have a y. So I factor just a 2. 14 divided by 2 is 7. It still has its my. And then 6 divided by 2 gives me -3. All right, now my question to you is, was this factor by grouping successful? You should say yes, right? Because we noticed that these 2 parentheses are exactly the same. So yes, we did it. Now the last thing we have to do is just rewrite, and hopefully you remember. To find your final answer, whatever is in parentheses, you just write it once. On the last problem, I put it at the end here. I'm putting it at the front. Don't worry about it. It's the same thing. So I put it in the front. And then in the other parentheses, you put what's in the front of the parentheses. So the 3m m squared y. I'm so sorry. There's a y missing here. Just go ahead and put it. And then the +2 goes right there. So that's my final answer, right? That's how you factor out. So just make sure you write it correctly on your notes. 7my minus 3, and then 3m squared y, sorry about that, plus 2. And again, that's how you factor by grouping. So make sure you have your notes handy. There are different ways to factor polynomials just depending on what kind of polynomial you have.